So thanks to both Beth and Gagli. So they have given a foundation for my presentation, I think. So as they mentioned, the work that I'll be talking about, right? So this is an ongoing work in Anuket's Thoth project. They gave a comment that it's more relevant to the LFN AI that's been recently. And you also saw the white paper that was published, this thing. So this is an ongoing work, and along with my colleague Rohit Singh Rathore, so we are working on this. We started this work when we started working, I think almost 2 years back on this Thoth project. When we started, we came across, we started using the available data sets, whatever the available. I think Orange had published some data sets. We tried to work on some of those data sets, and we tried to create some data sets on the Kubernetes setup. We ran some simulators using stress NGs and emulated some of the workloads, and we tried to create some data sets also. But eventually, it wasn't. We were not happy with the outcome, kind of thing. And we were thinking if we can build a tool to solve this problem of. So if you look at the why we started this whole thing is availability of data set. We'll come to the problem thing, right? The main message of this my whole presentation is today if you look at the anonymization domain, it's been there from last 20-25 years. People have been working a lot on anonymization in different fields. We don't have a single solution. I'm not referring, when I say a solution, I'm not referring to a single anonymization technique. It's a solution, overall single solution for all kinds of telco PII data, right? If we had that kind of solution out there, it would have been ideal scenario. But today we don't have such kind of solution which can anonymize all kinds of PII data. So we want, that work is all about creating that solution. Okay, we want to put in whatever that work already out there of anonymizing different types of PII data and put it together as a single solution so that we can take the solution to telcos and say, hey, is this worth it? Can you consider this tool and use it and see if you can consider sharing the data sets, kind of thing, right? So we don't know whether they will accept this thing or whether they will reject this thing. We don't know. It's more like a research activity that we are doing and integrating the available solutions out there and see whether this works and we can convince successfully the telcos to share their data sets. Okay, so we'll start with some basics out there. So what is the PII data that we have to agree upon? I think. So we did quite a few study, and we reached out to a few people and we came up with the initial set of PII that we want to consider. Of course, the names that that has been very well addressed over the last 30 to 40 years, kind of a thing, right? And addresses, all the IP and MAC addresses that are out there, and the mobile fields, that whatever IMSI or IMA, whatever we want to call it, different places that are available. And the location data, usually the cell ID and count are more or less enough. We don't need the GPS location information because unless the context is there, that's not really the PII is what the feedback we got. Whereas the cell ID and cell count are more important from the PII perspective. And lastly, some papers argue that some performance numbers, even the CSI, the channel state information, could also be a PII. That's why there's a question mark. We are not really convinced whether these kind of performance numbers and CSI can be a PII data. Some say no, some disagreement is there, some agreement is there. So it's just a question mark out there on that part, right? And as I mentioned, the problem, availability of telecom data set for AI and ML research. Today, if you see, it's difficult for telcos to share the data set for various reasons, right? They have their very valid reasons due to policies, privacy, legal restrictions, and various other reasons there. And it will never change, right? We cannot change that even in future. So that will always be there. And most of the available ones, if you see today, if you download from whatever that's available out there, majority of them are mostly from the simulated or emulated data sets. Even if you go and look at AI for good, right? IT use AI for good, and the data sets that are available out there, or CrewDAD, or there are so many websites that are sharing the data sets out there. Even ORAN SC project has the data sets that are there. Almost all of them are mostly from the simulated or the emulated environments. Okay, so what is the solution typically to solve these problems in other domains, right? Either people anonymize it or generate synthetic data generation, right? So when within the synthetic data generation, you do AI-based synthetic data generation using GANs or non-AI-based synthetic data generation. And within the anonymization, we have this classic, I will come to the quick overview of those classic techniques like K-diversity, L-closeness, and K-Anonymity, L-closeness, and I keep forgetting all these three things. Basically, anonymity, diversity, and closeness, the three things that are there, the classic thing. And the NLPs and the AEs, the autoencoders part. Right, and we want to build a tool that can anonymize all the existing data sets. Okay, and the tool should consider all kinds of PI data that we discussed earlier, and it should not affect the AI/ML performance, right? See, randomly just anonymizing, just blurring it out and removing some of the fields, not going to work, right? It should preserve the utility of the whole data set. Then only we can really make sense of the thing. And once we say, for example, preserving the utility could be like preserving the predictive power or detective power or these kind of things of the AI thing. It has to be, utility has to remain when you anonymize kind of thing. And we also looking whether, this is a statement that some people, like if you want to be very strict on it, you want to say, hey, these two are totally different. On the right side, you're telling it's two things are totally different, but can we look this synthetic data generation as an anonymization approach kind of a thing? For example, if I give a GANs model which can generate synthetic data for any types of PIA data, can telcos then use this model, use their real data set, generate the synthetic data set and share it to the world? Of course they would, I think there is very high chances they would do that, but it's not available yet. Only recently in SIGCOMM, almost a year back, I think Lin et al., I think they had done a very good work using GANs for generating packet traces, mostly an IP addresses field packet traces thing. That was a very, very good work almost a year back, I think, in SIGCOMM. So why synthetic data generation would make sense if you see, if you take these three categories, the raw data, anonymized data, and the synthetic data, right? Of course, raw data, its fidelity is high, but there's no privacy and no flexibility, and effort is very, very low. Anonymized data has some its advantages. For example, if you can remove everything, you can you can achieve a lot of privacy, but at times you lose the fidelity in that sense, right? And similarly, for synthetic data, right? It could be possible, but the effort could be very, very high when it comes to synthetic. So both anonymization and synthetic data generation has its own pros and cons, and depending on how you want to approach this thing. Yeah, but using GANs, of course, it will solve both the anonymization and synthetic data generation is what some of the arguments some people are proposing. So can this GANs-based synthetic data generation can also help these telcos to share their data set is what the eventual thing. But coming up with the GANs model for all kinds of data is really, really challenging. As I said, only like last year in SIGCOMM, we have a good publication on IP traces. So by anonymization, of course, this is just of basics we are covering. We are looking at all these types of things, ranging from suppression to masking, the pseudonymization, the generalization, swapping, perturbation, and the synthetic data. So that's why in our work, we have a separate team of students who are working on the GANs models. They are first reproducing that work I mentioned and trying to see if that model can be used for other types of data generation. We tried with some data. I'll come back to that point. And currently we are looking at these four things, the classic techniques, as I mentioned, K-Anonymity, L-diversity, and T-closeness, and differential privacy, the four things. And the NLP, we have a subset of students who are working on the NLP, and the autoencoders part, and the GANs part. So we are looking all these four things as a different, but mainly students. So we don't have any people in this project currently. It's only students who are working on this thing. Okay, I will just do a quick overview and then come back to the status of where we are now and what we have achieved till now, kind of a thing. Okay. Yeah, so we have this bunch of group-based anonymization, right? K-Anonymity thing. So I think it's been one of the most earliest ones of the classic techniques of anonymization, thing, right? So among the data set you have, like if each entity is contained in the data set cannot be distinguished at least against K or K-1 entities that are there. So for example, once you kind of anonymize the thing, there should be at least, for example, if K is 3, there should be at least 3 rows or 3 rows in this data set should be very, you cannot differentiate among those 3 rows, right? Depending on the K, what should be the K value? If you increase the more and more K, it will be the number of rows that would be very similar. You cannot differentiate among them, would be the high. So people have said, hey, this, for K-anonymization, we usually use either suppression or generalization, one of these two techniques. Then people say, hey, K-anonymity is not sufficient because, for example, I can say at least if I have some information, right, I could guess this person or this thing has one of this case on the right hand side. For example, let's take an example of names are there are ages are there, and some diseases are there. Some bunch of diseases are there in the 3 columns of the data set. Now I do the K-anonymity and group this thing, maybe heart diseases 3, let's take K is equal to 3. There are 3 rows which heart diseases with different names, kind of a thing. Now if if you give a age category some 30 plus or something, then I would know that, hey, this 30 plus person has at least a heart disease, kind of thing. So people said, hey, now within each of this K group, right, it needs to be diversity, right? So you cannot have just heart disease on this part. There should be at least diverse enough, kind of a thing. It should be, for example, in the same example, it should be heart disease or some other different diseases within the 3-member group, kind of a thing. So the L diversity was introduced on top of the K-anonymity. Once you group them into a bunch of these groups, within these groups, it should be diverse, kind of a thing. Okay. That was on the L diversity. Then and for this, we typically use the masking part of thing. Then the third, it was enhanced to include the T closeness, kind of a thing. So now within this group you have formed, the distribution that this group, how close, it's earth mover distance basically, right? So how close this within the group distribution is to the overall distribution of the data set. Okay, so this was again enhanced on top of this K-anonymity and L diversity with respect to T closeness. Then we have this differential privacy thing. So it's again based on either the randomized response for the discrete thing or adding noise to provide the plausible deniability. So DP is very, very popular, and even condensation based DP is the most recent, almost 2 years back. In one of the, I forgot the university name, it was used for anonymizing the networking related data sets. In fact, they got a good funding also on it. And we use perturbation in the DP, and within the DP, the mechanisms either is a Laplace, Gaussian, or exponential, one of these 3 typically. Okay, so autoencoders, right? So it takes the input data and breaks down into its bunch of discriminative features, or we can say like a latent vectors thing. And for different inputs, you will have a different latent vectors. A small change in the input, the latent vectors would be quite different, kind of thing, right? And quite different, rather, I would say quite distant in terms of and there are different autoencoders. If you look at autoencoders today, you will come across different autoencoders. One of the most relevant of the autoencoders is the VI, variational autoencoders. Okay, and it is just a deep generative model similar to the GANs. So you can use this also for generating the data sets thing. Okay, and so in this, the distribution of the encoding is regularized. That's where the term that VI comes into thing during the training part. The VI method is basically like it's approximating the probability density through the optimization process thing. Okay, so the latency, eventual latent space will be sufficient enough properties for it to generate a newer data set. So it's used well to anonymize the image data. And very, very recently, there are works around anonymizing the time series data. That's which is relevant for us in this case. Okay. NLP is, you all know very well about NLP. It's basically a computational linguistics with the AI and ML the approaches that are there. You combine these two things. And this is the typical flow if you used NLP for an anonymization process, right? Microsoft has a Presidio library that is there, which we all use that Presidio library, and we are testing out that one very well now. So the goal is to first recognize the patterns, detect NER, detect entities, then validate. You add any context if required, then go ahead and anonymize it. So this is the classic flow that we use with the Presidio library, the Microsoft's Presidio. And we have used extensively for textual data. So in our case, we are working with this with the log data. So whatever the logs that we are collected, and we think that this logs data might have some PII information, and we are exploring, can we use this NLP techniques for this log information? Okay. And GANs, basically the training data, you take it, and that training data follows some distribution, okay? And the whole idea of this GANs is to generate the synthetic data that also follows the same distribution, or at least close enough distribution, right? And it is achieved through adversarial training, right? So there are two competing models. Basically, the generator maps the low dimensional noise to an output samples kind of thing. And we have this discriminator, which I think once these two models, both the generator and discriminator, are both the neural networks and are trained in attenuation to convergence kind of thing. Let's not go deep into. So if we started on all these four things in parallel kind of a thing. We wanted to do a study. So if you look at the phases of our work, right, we have this experimentation phase. This is the longest time we are spending on the experimentation phase. We are working on collecting the data sets, playing around these data sets, and see whether they are sufficient enough, what's missing of these available data sets thing, and the techniques that are there, then the models that are out there, and do we need to do anything change. And depending on this experimentation phase, then we'll have to start developing some of the models and some of the tools around it, and finally the evaluation phase. So currently we are almost finishing the output of my first phase is to basically the PII scope, what should be the PII thing, what are the gap analysis, the mapping of the PII data and the techniques. For this PII data, this technique is good. So we are trying to see if we can do some kind of mapping of that thing. Once we do that, then in the next phase, we want to release the first version of the tool that we have. I'll just show quickly the architecture. And lastly, the final version. So we are still in, you would say, the end of this experimentation phase. All the four things we are trying and working and see if we can complete those things. As I mentioned, we are only relying on students, and it gets very difficult. And they are not, they are volunteer students who are volunteering for it. I mean, there's no obligation for them. And we are not their professors. So we cannot really get the work done by forcing them to do that. Okay, now I'll just answer for 4 or 5 questions to the status where we are now going through. With respect to the data sets, right? So if you take all these 4 different things, we do have some good amount of data sets on these things, starting from the names or the logs that are there, the addresses, the mobile fields and the locations. Location was pretty good according to us. The OpenCell ID, if you go to the OpenCell ID, we downloaded for different countries, and we are working on different countries' location ID information that are there. But what's missing is the logs are still where it's not sufficient or still not relevant to the telco domain, the logs that we are looking for which we can run NLP on these logs. And context is still missing on mobile and location. So what we are doing currently is we have taken that very popular adult data set and added these kind of IMEIs and these numbers to that adult data set additional column, and using this classic techniques and use that as the PIA column and run on that data set. So today we are taking that as a shortcut because we don't have that sufficient context around IMEI and mobile data set. Okay, and with respect to classic techniques, right, that are out there, the names, there is no issues at all. They have been extensively being used in different fields, starting from healthcare and different fields. So we are more or less there to do that. IP and MAC address also, this is like one of the most researched areas. If you want to do anonymization around these two, over last 20 plus years, people have been doing this thing. And there are various implementations that are available. And as I mentioned, you can use GANs also to generating packet trace. Zina and Lin, it was very good publication in SICOM in last year, I think, yeah. And condensation-based differential privacy thing. Implementation is not available. We are reproducing it. One student is working on implementing that thing because the paper, if you look at the paper, the difference was very significant. We reached out to authors, they no response. So we are trying to implement it and reproduce it and see if it's really that good. So rest of them like mobile fields, and we don't have the data set for these fields or not any reference works. So we are working, as I mentioned, the techniques that we are working and trying out the classic techniques on them. With respect to these NLP, AEs and GANs, how these three groups are, what are they doing now, right? So as I tried, we are working with Presidio on the available log files. With the proper lack of log files, we are still like not happy convinced with that completeness of the work. So we have started an internship program thanks to Beth and Gagley. So they gave some resource for us to bring in an intern to complete this NLP work thing. So we'll be starting mid-May. By end of July, we should be able to wind up this NLP based approach. And AEs, we are trying both the traditional and the VAEs part. And VAEs also can be used with synthetic data, and we are also trying the DPA VAE, differential privacy VAE, and we can improve the privacy part of that also in this case. I don't have an answer yet now what's happening with that. It's still a work in progress. GANs, as I mentioned, we first tried with ITU for good. We created this as a problem almost a year and a half back. We were the host of, Anuket was the host of this problem. We were 5 teams took the challenge. I think 2 teams kind of completed. When we looked at their outcome and their results, it was not really convincing enough for that particular data set. So we created a set up a Kubernetes testbed in Anuket. We ran this workloads, some of the telco workloads, and we emulated some of the workloads using StressNG. We created this data set of the infrastructure and then shared this into the ITU problem. Yeah, we were not really happy, but we are currently reproducing the SICOM work, as I mentioned, and that looks very promising with respect to IP and MAC addresses fields. Now, mapping of this type of the PIA to a technique, right? This, of course, is the output of the milestone 1. So what kind of sensitive information is well suited for each of these techniques, right? So this is a very important question out of the milestone 1 that we want to answer, right? For the classic thing, anything numerical and some categorical types can be still used with the classic thing. And NLP, of course, the textual, what are the PIA and the logs. The autoencoders, mainly the names, images, and the audio, if any, but evaluation with the time series is still ongoing. We will have to see how good these AEs can be used for the time series. Yeah.
I have a quick question about that. So PII, like the European standard, that includes IP addresses as being considered privacy. So
it is included. IP addresses are part of it. IP and MAC, that's what you mentioned, IP addresses, right? Yeah. IP and MAC, we both are considering. Both the addresses are considered, yeah. And the GANs, IP or MAC can be used, and some numerical thing, and images, if any, but we don't foresee any image-based PII yet from the telco thing. Of course, I don't know, I may be totally wrong, maybe the thing. Okay. this is almost last slide. Okay. Okay, so the final slide, I think. So can we use the existing works to build the tool? Yes, we can, but we'll have to do a lot of prepare the data set, work on logs that are missing, and it takes a lot of manual effort. For example, if telco gives us the huge data set, now we have to identify what are all types of PII out there, and we cannot do that manually. We had to automate that whole process. So we have to, the first part of our tool will go through, so this is the raw data set comes, we have this PII detector as the first tool. The PII detector will detect what are all the types of PII that are out there in the data set that are given. Then, depending on that PII detector output, we have this pod manager. So each of the anonymization technique is a separate pod. Okay, so this pod manager, depending on the output of the PII detector, it will spawn different pods that are related to the thing and send that data, particular data set to those pods and collect the anonymized output from each of those things and push it back to the anonymized data thing. So this is the architecture of our tool that we have for now, and we are building that 81, 82, 80N anonymization technique 1, anonymization technique 2, like that for each of the PII data set that's out there. And we also have this kind of data manager thing. So this is the rough architecture of our tool for now, and we are using thing. So finally, we want to see if we can run it on the Kubernetes environment. It will automatically detect the PII information and spawn pods accordingly. Okay, so this will be the eventual outcome. I think my time is almost up. So thanks, join Aniket. Join us this thing and see if we can support our initiative. Okay, any questions? Okay, I think I'm almost, 1 more minute is remaining. Okay, thank you so much.